So 2.4 is on rational exponents. And in the beginning of Unit 2, we worked with just exponent rules. And so as we look at this, we need to just recognize that really we're doing the same thing. The only thing that's going to be a little bit different for us is that sometimes our exponent will be written as a fraction. So if the exponent is a fraction, it's called a rational exponent because a rational number can be a fraction. But if you look at the main idea here, all the same rules that we've talked about before are true for rational exponents, just like they were for integer exponents. So nothing has really changed except for the fact that you're going to be working with fractions, which isn't a big deal because we can use our calculator if we need to. So notice as we're looking, our first rule again is if the bases are the same, then we add our exponents. Nothing is different when I have fraction exponents. My base is still 3 for both of them, so my base stays 3, and then I add my exponents. So 1/2 plus 1/2 is equal to a whole, which if it's a power of 1, we don't really need to write it. We can just write it as 3. If you have a combination of numbers and letters, then remember the real numbers we multiply, just like before. So 3 times -4 is -12. Our variable is m, and that's the same base, and so we're going to add our exponent. So I'm going to go 5/4 plus 1/2. If you struggle with fractions, then in your calculator, we can just do that. We're going to go 5/4 plus 1/2. And we're going to get a decimal answer. And when we get our decimal answer, we push math and then enter twice, and it flips it back to our fraction for us, which is 7/4. Another option is you can multiply and get a common denominator. So we're like, oh, we need a 4 in the bottom. So if I multiply the top and the bottom by 2, then this becomes 2/4. And so we get 5 plus 2, which is 7. So either way, you're going to get 12m to the 7/4. It's just dependent on you if you are good with doing fractions by hand or if you want to use the aid of a calculator. All right. If it's division, the same thing happens. So division, we subtract our exponents. So again, your base is the same. We subtract exponents. So my base is the same here. I've got a v and a v, so it stays v. And then you're going to go 1/2, subtract 3/2. And again, when you use your calculator or whether you notice that your denominators are the same, 1 subtract 3 is -2. Denominator stays the same. That's v to the -1. We really don't like negative exponents, and so we move it down to the denominator to make it positive. When I look at my second example, I've got regular numbers here, and then you have your v's. Okay, regular numbers, 6 divided by 12. Notice that the 6 is on top. So when I reduce that 6/12, I get 1/2. So my number part is 1/2. And again, that's because I'm just taking the number part and simplifying. And then you have v, and we take the top exponent and we subtract the bottom exponent. Again, we can do that by hand or we can use our calculator. I know a lot of you guys aren't great with the fractions, so we might want to use your calculator. And so let me see if I can make this a little bit bigger. All right, so then if you've got 5/2, 5/2, and then we're going to subtract 3/8. We get our answer. We have a decimal, so we're going to go math, enter twice, and it's going to flip our fraction for us. So you'll notice that it's 17/8. Again, if you're looking at that, we can also do it by hand. If you do it by hand, remember that you need the 2 to turn into an 8, so you're going to multiply the top and the bottom by 4. So this becomes 20, and the bottom becomes 8. And then 20 minus 3 is 17, and the bottom stays 8. So it's whatever's easier for you. When it's a power to a power, remember our rule is to multiply our exponents. Same thing when our exponents are fractions. This is going to go n. We multiply fractions by going top times top. So 3 times 1 is 3. Bottom times bottom, 2 times 2 is 4. And that's my answer. If you're doing 2/3, remember there's an exponent of 1. And we just distribute that to both pieces. So we're going to get 5. 1 times 2/3 is 2/3. And then we have n. And then 1 times 2 is 2. 4 times 3 is 12. And then we can reduce that. So this will be 5 to the 2/3. And then n to the 2 over 12 is 1/6. You guys can use your calculator for multiplication as well. Just remember you've got 1 divided by 4 times 2 divided by 3. And you're still going to get 1/6. When we're looking at a fraction being raised to a power, and we remember multiplied the exponent by both of the exponents inside, same thing happens with our problem here. We're going to have x. We're going to go 1/2 times 3/2. So 1 times 3 is 3. 2 times 2 is 4. And then we do the same thing on the bottom. 3 times 1 is 3. 2 times 2 is 4. And now it's a division problem where the bases are the same. And so then we can subtract. So this is x to the 3/4 minus 3/4, which means that you've got x to the 0, which gives us 1. Now we could have also simplified first. So if I was going to do this problem a different way, I could have subtracted first, and I could have gone x to the 1/2 minus 1/2, and then all to the 3/2. And then 1/2 minus 1/2 is x to the 0, and I'd still raise it to the 3/2, but then 1 to the 3/2 is still going to be 1. And so either way I'm getting 1 is just dependent on if you want to distribute first, or if you want to simplify first and then do the power to a power. Get the same answer either way. So here, same idea. If I want to simplify first, I can go 4 divided by 2, which is 2. I can subtract the 1/4 minus 1/2, which is going to give us negative 1/2, or negative 1/4. And then we're going to raise it to the 5/6 power. And then you distribute. So this will be 2 to the 5/6, x to the negative 5/24. And then because it's a negative power, we move it down to the bottom. So this is 2 to the 5/6 over x to the 5/24. You could have distributed the 5/6 to everything first. But in this case, for me, when I notice it, I don't want to have to do distributive property 4 times. And so for me, I'm like, well, yes, I could do that. But when I look at it and I notice that I've got things inside that simplify first, I like to do that better. It makes it a little bit easier than trying to worry about giving that power to everything, because sometimes that is more work than you need. All right, so when we look at this last idea, our last little rule was, and we've kind of already talked about this earlier, if you have a negative 1 power, to make it positive, you move it down. If you have a negative power in the bottom, then you move it up, okay? So remember that it's kind of like there's a 1 down here. So if it's a negative power up in the numerator, then we move it down to the denominator and make it positive. And then we always remember there's always a 1 next to it. So that's why I get 1. So when we look at the negative 1/2, it just comes down. Okay, or if it's a negative 3/2 in the bottom, it comes up. If you're given anything to the 0 power, it's 1. And you've already seen this as well. So if this is 1/3 minus 1/3, because it's division, so we subtract, this is x to the 0, which is 1. And we saw that up above. And the same thing here. Even though that's a whole bunch of gross stuff inside, anything to the 0 power is 1. Don't try doing anything inside. If you see that 0, then you know that you're done and you're good and it's 1 and life is happy because we don't have to do all the work. All right, so that's everything for your 2.4 notes. As we look at the last little bit, it just talks about how you can rewrite a radical in a different form. Like you can go from a radical to exponential form, or you can go from exponential form to a radical. And so what that helps you see is that as you look at your form, the P is your power, and the R is called our root or our index. And we can just rewrite things however they are going to look. So for whatever reason, these look a little bit crazy. Your notes do. So or my notes, if this is a 2, then that's going to be the number that sits on the shelf or as your index number. And then this is X. Most of the time we deal with square roots. What happens is we don't really put that index there. So x to the 1/2 power is the same thing as just taking the square root of something. So when there's not a number there, it's like there's an imaginary 2. But if I was looking at example 2, then the 5 sits on the shelf, or is your R value, and the x to the 4th is on the inside. Another way that you might see this is that you might see 5 on the shelf and then x underneath, and the whole entire thing being raised to the 4th power. These actually mean the same thing. So just be aware, like I don't need to have the exponent on the inside. The exponent could technically be on the outside as well. All right, so it could be like this, raised to a power. And then if we're going the other way, so we're writing in exponential form, you have x, the 3 is your denominator, and the 5, or your power, is the numerator. So x to the 5/3 is the same thing as the cubed root of x to the 5th. And then our last little one, remember I talked about how if there's not anything there, there's really a 2. So this is x, the power is your numerator, the index or the root is your denominator, and then we can simplify this. 6 divided by 2 is 3. Now I think we're done for the notes for this section. All right, so ask if you have any questions, and we'll just end it there.